Okay, as we continue with 1.2 Part 1, you are asked to use your graphing calculator to sketch the function x squared minus 4. Now, if you have your graphing calculator in front of you, you know what you should do. You should be typing in Zoom 6. Then you're going to go to the y equals button. You're going to type in the x that's next to the alpha key. You're going to hit caret 2. You're going to hit the gray minus button, and you're going to hit the 4. And then you're going to push the graph button. And when you do, you're going to come out with a picture of a parabola. We knew it was a parabola because of degree 2. But it's going to be touching the x-axis at 2 and negative 2, and it's going to be touching the y-axis at the ordered pair 0, negative 4. Remember when I ask you to graph something for me? What I mean by the best graph, okay? If you were copying this onto a test for me, I would want to see a dot on negative 2 and 2 and a dot on negative 4. The negative 4 is easy to find. If you push the trace button, that will give you the ordered pair 0, negative 4 automatically, which is the y-intercept. These two ordered pairs are easy to find by looking, and they're also easy to find in the table. If you went to the second function key and selected table, you would see 2, 0 and negative 2, 0. Okay? So here is our graph of the function y equals f of x. Now, using the graph only, in other words, don't plug in using algebra, find f of 0. Okay, here's what I'm testing you over. F of 0. F is the name of the function which we have the graph of. That's function f, the graph of f. 0 is an x value. When I put in the x value of 0, okay, so here's my x value of 0. When I look up, I don't see anything. There's no graph. But when I look down, I see the graph. And where do I cross the graph? What y value is there? Negative 4. So f of 0 would equal negative 4. And a way to corroborate that, if you turned this statement in your mind mentally into something that involved an ordered pair, f of 0 equals negative 4 would mean that the ordered pair 0, negative 4 is on the graph, which it is. Okay? Let's find f of 2. F is the name of the function. 2 is an x value. When I go to the graph on the x-axis and I find 2, I don't have to look up or down to find the graph. I'm already on the graph. What's the y value where I'm standing? Well, hopefully you know on the x-axis the y value, the output value, is always 0. So in this case, when I put in a 2, I get out a 0. And a way to corroborate that, the ordered pair 2, 0, the ordered pair 2, 0 is on the graph. Okay, let's play with this one. F of negative 2. F is the name of the graph. Negative 2 is an x value. Go up to the graph on the x-axis and find negative 2. I don't need to look up or down to see where the graph is. I'm on the graph. When x is negative 2, I'm standing on the graph. What's the y value right here? 0. F of negative 2 is 0. And a way to back that up is when negative 2 goes in, 0 comes out. Negative 2, 0 is on the graph. Okay? My final thing that I want you to be catching, but hopefully by now you've caught what I'm going for here, and that is being able to read a graph visually. F of 1. F is the name of the function, i.e. this graph. 1 is an x value. Here's 1. X is 1. Do I look up and see the graph? No, I have to look down. When I look down and see the graph, okay, I walk down, look where I end up touching the graph. It's at the same level where y is negative 3. So f of 1 is negative 3. And the reason you can back that up with geometry, when you put in a 1, you get out a negative 3, and the ordered pair 1, negative 3, 1, negative 3 is on the graph. 1 goes in, negative 3 comes out. And we're done.